Okay, today we're looking at Module 4, Lesson 23. I realize the slide says 23 and 24. Last year I was able to teach these two lessons in one day. Since we have the shortened periods today, we can't. But 23 and 24 are very similar. Okay? So let's take a look first by reviewing some vocabulary. Okay, so what does that first symbol mean? Equal. Right, so is equal to. So 4.5 is equal to 4.5. What's the next symbol?
Greater than.
So 5 3/4 is greater than 5 1/2. Next symbol?
Less than.
So 4 2/5 is less than 4 3/5. Now this next one. Yes, I'm just picking random examples. These are just coming from Lebusky land.
Ooh, like that.
Okay?
Less than or equal to?
Right. So now two rules apply. Is less than, or it can be equal to. So if I say 6 is less than or equal to 6, is that a true statement?
Yes.
Yes, because it's equal to it. 6 is equal to it. Suppose I said 5 is less than or equal to 6. Is that a true statement?
Yes.
Yes. So it can be one or the other, less than or equal to. And the last one? What's the last symbol?
Greater than.
Is greater than or equal to. So to answer your question, 6 is still greater than or equal to 6. But also 7 is greater than or equal to 6. So those are both true statements. All right, so let's see how we could apply this. Right now you can put your pencils down. We're just going to talk about this a little bit. So here it says for each inequality or equation. All right, well, first of all, let's go over what that means. Look at my first example on the board. 5 plus x equals 8. What do we call that whole thing? What is that whole thing? That's an equation because it has an equal sign. But now what about when we say 5 is greater than 4? There's no equal sign because those are not equal. So if they're not equal, they are unequal. So we can call that an inequality. So if you want to go back to your first chart and maybe draw a bracket to the bottom 4 and in your margin label those as inequalities, if that helps you, you can do that. Okay, that's an inequality. So now getting back to this list, we're going to determine that x equals 3. Okay, that's just a given. Where did that come from? It came from the land of because I said so. All right, so x equals 3. That's usually you'll see the word given. That's given to you. That's a given. Your pencil is still down, okay? So let's replace x with 3 and see if it's a true or false statement. So I first write the first equation. I replace my variable with the value. I follow my laws of PEMDAS. Is that true or false, this equation? That is true. So here I place x with 3. I follow my PEMDAS rules, top to bottom. Know where's Waldo work, like a ladder. Is 8 greater than 8? No, that's false. 8 is 8. 8 is equal to 8. So 5 plus 3 greater than or equal to 8. Is 8 greater than or equal to 8? Yeah. So now this is a true inequality. So this is 5 times 3 equals 8. 15. Does 15 equal 8? Nope, that's false. So let's change our symbol. Is 15 greater than 8?
Yeah.
Now that's true. So what we're going to do now together on page 108, there'll be a series of equations and inequalities, and they're also going to tell you the value of the variable for each one. So we have 2 jobs. Solve it, determine if it's true. If it's true, say what would make it false, and if it's false, let's determine what makes it true. So we'll do these together. So take a look at number 1, 4 plus x. You don't have a lot of room, so you could write your explanation next to it. I'm going to go top to bottom. So 4 plus 8 equals 12, because it's telling me over here x equals 8. 12 equals 12. So when x equals 8, that is a true statement. What would make that a false statement? When would that be false?
If you say that 4 plus x is greater than 12.
Well, I want to find a different value of x. That's what I meant.
Oh,
I'm sorry. I understand where you went with that, and you're not wrong. What I should have explained is I want to find a value of x that would make it false.
Like x being 6.
X could be 6. So, it will be false for any number other than 8. 8.1, false. 8.01, false. 7.9, false. So you need to write this statement next to number 1 on your paper. You don't have room below it like I do, but you can write it next to it. Okay? It will be false for any number other than 8. Let's look at number 2. 3g is greater than 15. G equals 4.5. So 3 times 4.5 is greater than 15. What's my rule for multiplying fractions? What do I have to do to that mixed number before I can multiply it? I could change it to a decimal. That would work, and that would make it easy. What's my other option? Well, I'm going to change it to an improper fraction just so we can review fractions for a minute, okay? So 3 times 9 over 2 is greater than 15. So 27 over 2 is greater than 15. 2 goes into 27 13 times with 1 left over. So when g equals 4.5, is that inequality true or false?
It's false.
Right. So g equals 4.5 is false. Or if you want to say g does not equal 4.5, what would make that true? Well, wait a minute. I know that 3 times 5 is 15. So if g equaled 5, 3 times 5 is 15. Is 15 greater than 15? No! So when G equals 5, so what would have to be true?
It has to be higher than 5.
So to make it true, so any number greater than 5, so 5.1, 5.01, 5.000000001, anything that is just a smidgen larger than 5, or a lot bigger than 5, is going to work. All right, let's continue with the next one. So f divided by 4 is less than 2. Let's substitute f with 8.
So 8 over 4. What makes that
Is 2 less than 2?
No.
So it's false that f equals 8. What would make that true? We just have to make 2 a little bit smaller. So it has to be anything less than 8. It will be true for any number less than 8. 8 was just a little too big because we don't want it to equal 2. We want it to be a little bit smaller. So that means we have to make 8 a little bit smaller. All right, let's try number 4. They're saying h equals 25.8. So 14.2 is less than or equal to 25.8 minus 10.3. Coming over here to my margin, I can't subtract those decimals in my head. Well, why should I? So I bring down my 14.2. I bring down my inequality symbol. 25 and 8/10 minus 10 and 3/10 equals 15 and 5/10. So is that statement true? Is that true? So h equals 25 and 8/10 is true. What would make that false? What would all of a sudden make this less than 14.2? This one's a little tougher. We could figure out what would make it equal and then say it just has to be less than that. So what is 14.2 minus 10.3? Nope, I did that wrong. Plus. So any number. This one was a little more challenging. Any number. Gentlemen, please stop talking and copy your notes. Let's get one more done, number 5. So 4 equals 8 divided by 6. I need it to equal 4. What is 8 divided by 6? So it's going to start repeating. So does 4 equal 1 and 3/10 repeating? What is the only thing that D can equal? 8 divided by what would equal 4? 8 divided by what would equal 4? So 2 is the only number that will make this true. So this was false. That 6 equal D. So 2 is the only number that will make this statement true.